Hey everybody, this is the kind of a tutorial, but it's the answer key for the 2021-22 Rocks CER Key. So as I explained, or as it says on the sheet, that this is just a practice test. And you're going to be taking the actual test in a few days. And it's going to be based on some of the data that you've taken from a lab. If you don't get to the actual lab, that's fine. I did the lab myself, and I'm going to use my data. That way it ensures that everybody's using the same data. So for the practice, this is the scenario. This is what you read. It says, please read the prompt and look carefully at the data table. Use the information to write complete and accurate claim, evidence, and reasoning statements. A student found two rocks and would like to figure out if they are the same type of rocks or different types of rocks. Below is a table with some information about the rocks and scientific principles you may use to complete your statements. And that's huge. I know the first couple tests that we've taken, whether they're practice or whether they're actual graded tests, some of you didn't use the data at all. You just made up data. You made up your own data. You need to use the data that's provided. That way I can accurately figure out if you can utilize the given data. So when you look at this data table on your sheet, hopefully you use this data. If you're just making stuff up, my question to you would be, why? It tells you to use it. You just need to use it. So it says use the information in the table, the data table, and the scientific principles to write a scientific explanation, which is a CER, that answers the following question. Are rock 1 and rock 2 the same type of rock? And it says please write your answer in the space below. So here's my tip for this one. Hopefully you answered this question. I would say I have about a dozen students who, when we took our last test in class, you never answered the question. I don't really know what you were answering. The question is, are rock 1 and rock 2 the same type of rock? So your claim should answer that question. All your evidence should be to support your answer for this, and that should be in your reasoning as well. So once you have the question, now you have to look at your data. Are rock number 1 and rock number 2 the same type of rock? So if you look through, you've got mass, you've got color, you've got hardness, you've got density, and you've got melting point. So if I look at these, the mass is the same, which is pretty impressive if you have two different rocks and they're the exact same mass. They're both colored light green, but here, let's look at hardness. Hardness is a 7, and for rock 1, and rock 2 is a 4. And the densities are different as well, and the melting points are different. So does that mean they're a different rock? Well, let's look down below. So we really need to consult the scientific principles. So a property such as density, which is mass divided by volume, is a unique characteristic that helps identify a substance and distinguish one substance from another. So it is unique. So if I look at the rocks, they have different densities. So I already know right now that rock 1 and rock 2, they are not the same. They are definitely different. Now, if we look down below, a substance is made up of only one type of material. Well, no, that has nothing to do with what we're trying to figure out today. 3, a mixture is made up of more than one substance. This has nothing to do. It's true, but it has nothing to do with what we're asking. Are rock 1 and rock 2 the same type of substance? 4, solubility. Solubility? And it says solubility is a unique characteristic that can be used to identify a substance. But if I look up here, I have mass, color, hardness, density, and melting point. I have no solubility, so 4 doesn't make sense. I shouldn't use that. 5 is hardness. Hardness and melting point are both properties of substances. Melting point is the temperature at which a solid substance starts to become a liquid, and melting point and hardness are unique characteristics. Unique. So we look up above, melting point is one of them, and they have different melting points. And hardness too, they have different hardnesses. So even though the mass is the same, even though the color is the same, because they have a different hardness, a different density, and different melting point, they are different types of rocks. They just both happen to be the same mass, and they both happen to be the same color. There's lots of rocks out there, and lots of rocks have different colors. So we're looking at number 1 for the scientific principles, and we're looking at number 5. So we can make a claim now. My claim is rock 1 and rock 2 are not the same type of rock. So that would be a good proficient claim for you. If you just say rock 1 and rock 2 are different, you got to get a little bit more detail in there. What I would do is I would just go back to the original question. Are rock 1 and rock 2 the same type of rock? And I would just kind of repeat this. Rock 1 and rock 2 are not the same type of rock, or rock 1 and rock 2 are different types of rocks. So use what you have in the original question in your answer. So what is my evidence for this? Well, we just went through the whole data table together. Well, rock 1 and rock 2 have different hardnesses, but don't stop there. You need to use qualitative and quantitative information. So this would be more qualitative, but quantitative. Well, rock number 1 is 7, and rock number 2 is 4. And I'd probably even have maybe like rock number 1 has a hardness of 7, and rock number 2 has a hardness of 4. Now they have different densities. So again, you don't just say rock 1 and rock 2 have different densities, but what are those densities? This is where, if you want to be proficient, you have to use the numbers. So make sure you include those numbers. And the same thing for the third thing, we know they have different melting points. You want to label those melting points. You don't want to just say, oh, and I'm afraid some people might say that, say, oh, rock number 1 and 2, they have different hardnesses, densities, and melting point. You would only get a developing for that because you're not as detailed as you need to be. So you want to make sure you have both qualitative and quantitative. Quantitative meaning numbers. And just saying rock 1 and rock 2 is not good enough. Now, could you mention mass? You could. The mass does not matter as it is not a physical property. Mass only indicates the quantity. And you could have a rock that's the same rock, but they have different masses just because it's a bigger version of that rock. And again, you could talk about the color. You don't necessarily have to have this, but this would be the difference between a proficient and an advanced score for your evidence, that you talk about why the mass and why the color is not good evidence. So let's look at the hardest part, the reasoning. So the very first thing you always want to do in a reasoning is restate the claim. Rock number 1 and rock number 2 are not the same type of rocks. Okay, so now that you've done that, you've got to talk about each of the scientific principles. So notice right here, I actually bring up scientific principle number 1. I state it, or down here I says SP number 5. You want to tell me that, hey, scientific principle number 1 is important. And you do that by saying scientific principle 1 states that a property such as density, which is mass divided by volume, is a unique characteristic that helps identify a substance and distinguish one substance from another. You don't just read off, oh, hey, density is a unique characteristic, blah, 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 but you say scientific principle number 1 states. Because that way you're taking me, the grader, the person who's determining your grade, and you're saying, hey, look, I have the scientific principle in there. And once you put the scientific principle in there and you state it, now you have to explain why that's important. Well, rock number 1 and rock 2 have different densities. Rock 1 is 6.25 grams per cubic centimeter, and rock number 2 is 8.96 grams per cubic centimeter. So you not only have the scientific principle, but why is the scientific principle important? Now you notice that I just copied and pasted these. Actually, all 3 of these were copied and they were pasted here. I might have to, work the wording just a little bit, but I didn't have to rewrite anything. And that's the beauty of doing this online. Now, that's not the only scientific principle. We also have to talk about hardness and melting point. So again, bam, right here, scientific principle number 5. That draws my eyes to it. Now I know you have both scientific principles. For those of you who paraphrase things and you don't say, hey, scientific principle number 5 states, I have to look at your work and determine, did you really talk about it? Did you not? This tells me that you did. So I just restated it, and then what did I do? I copied and pasted data in here. Well, rock number 1 and rock number 2 have different hardnesses. Then what are the hardnesses? Well, it's 7 and 4. And then I talk about the melting point. Rock number 1 and rock number 2 have different melting points. 450 degrees Celsius versus 2,576 degrees Celsius. Again, what did I do? State the principle. Then I have to explain why the principle is important by putting the evidence in there. Now, if you had that, you could end it with, therefore, Rock number 1 and rock number 2 are not the same type of rock. That would be proficient. If you want advanced, go ahead, talk about how mass is, it can't be used. It's not a physical property. It can't be used as a physical property to identify something. And mass only indicates quantity. Scientific principle number 6 states that properties of a given substance are the same regardless of the amount. So you could use scientific principle number 6. That would be good for an advanced score, but you definitely don't need it. And rock number 1 and rock number 2 do not have identical physical properties. Therefore, they're not the same type of rock. So you always have to end with a therefore statement or a conclusion statement. So remember, and you can use this, you can watch this video while you're taking a test. You won't be able to use it to answer the questions, but you can go through and say, okay, do I have, you can create like a checklist. You can go through and say, okay, in the reasoning, did I restate the claim? Did I mention all the scientific principles? Did I explain why the scientific principles matter? And that's what you see in blue. And then do I have a conclusionary statement? So hopefully you did well in the practice. In a few days, you're going to take the actual assessment, and you're going to be using that. It's going to be based on the rock density lab that you did in class. So hopefully you understand density. Hopefully you understand rocks, and hopefully you will use this video. Or remember, if you're taking a test here in class, you can use the posters on the wall, the CER posters. They tell you what to put in it. And then hopefully you'll do a good job. And some of you may be done taking CER tests for the year, because this may be the second one that you're proficient on. So as always, if you have questions, if you don't understand something, please ask.